of a problem that you'd have to do. Alright, so a calorimetry problem is when you're putting like a hot metal or cold metal into some water, or a rock or something into some water, and one thing's increasing in temperature, the other thing's decreasing in temperature. So the first thing that you need to do is make a list of what you have. Okay, so we have a metal and we have water. So I like to make a list of water, and I like to make a list with metal. And for those things, we need to know the Q, the M, the specific heat, the initial temperature, final temperature, change in temperature. We're going to need to know that for both. So I just make a list. That helps me keep track of things when I read the problem. Okay, so 24 grams of an unknown metal, that's the mass of the metal. With a temperature, okay, so that's the metal temperature, is 120 degrees Celsius. It's placed into a calorimeter containing 100 milliliters of water. Well, that's going to be your grams of water. 100 milliliters will equal 100 grams. And the water has an initial temperature of 23 degrees Celsius. After a few minutes, the water stabilizes at 31 degrees Celsius. So that difference will be 8 degrees Celsius. The water changed 8 degrees, final minus initial. The specific heat of water is 4.18 joules per gram degrees Celsius. Okay, so now, anyway, a couple other things is the final temperature of the water should be the same as the final temperature of the metal. And so the change in the metal is equal to a negative 89 degrees Celsius. Okay, we're looking, it says what is the specific heat of the metal? So we're looking for C, but we don't know the Q. How this works though is we can find the heat that the water gained to increase in temperature that will be equal to the heat that the metal lost. So we're going to start with water, and we're going to go use Q equals mc delta T. Then we're going to plug in the numbers for water. So the mass of the water, so we're using all water data here, times the specific heat of the water, okay, times the temperature change of the water, which is 8 degrees Celsius. So the water ends up gaining, if you do all the math there, 3,344 joules. That must mean that the metal lost that many. Alright, so now, so the trick is the water gains 3,344, the metal loses the same amount. Now you can transfer that over here. Now we have enough information to solve for the specific heat of the metal. So the specific heat of the metal, which is C, will equal the Q, the heat, over the mass times the change in temperature. So now we plug in the numbers. Specific heat is 3,000, or the heat, not specific heat, 44, that could be negative. That's going to be in joules, divided by the mass, which was 24 grams. Notice how I use the mass of the metal. Now I'm using this C data right here. This is all metal data here. This is all for metal. So I'm using the mass of the metal times the change in temperature of the metal. That's negative 89 degrees Celsius. And so when I do the math here, I get that my specific heat is equal to 1.5 joules per gram degrees Celsius. Notice that two negatives make a positive. And so when you're trying to calculate a specific heat, you will never get a negative specific heat. So if you goof up one of your signs, just make sure that your specific heat is always positive. That's it. Now